All right, so we took the Chapter 7 test last class. If you have not taken that yet, please get that done as soon as you can. If you need any help, please let me know. Chapter 8 builds a ton on Chapter 7, so if you didn't do very well, also if you did already take it and didn't do very well on the Chapter 7 test, make sure you do some of the remediation, or you come and talk to me. Now, if you take a look at the calendar, Chapter 8's going to be done. Like, if you blink your eye, you're going to miss Chapter 8. We're only doing 8.1 and 8.2 in Chapter 8. We will do 8.3 later. So how we break this up is we do all the proportion stuff with inference first, and then we do the mean. So we do separate them here. That's why it is so quick. So read through the learning objectives, please, sometime, and then notice the things that you need to do on this. So on Wednesday, the quiz will be open. If you're watching this Monday or Tuesday, make sure you do the 8.1 homework in the book. If you don't have access to the book, please let me know. All right, so let's go through these guided notes. So I'm going to have the students, as they walk into class, they're going to grab a bead. And if they grab a red one, they're going to win a little gummy bear pack. So the question's going to be, what were your chances of winning? What was the proportion of red beads in this big jar that I had? And we ran out of time, so I didn't make them all have a random sample of 20 beads. We just had a class random sample of 20 beads, which did throw off the activity a teeny bit, but we're still going to go through this, imagining that you all took your own individual sample. All right, so here's our sample right here on number 1. We took a pea hat, or we took a sample of red beads, randomly just reached our hand in there, grabbed out 20, and then we counted how many were red. And so I got 7 out of 20, which means we're thinking there's about 35% that are red. This is our point estimate. So your statistic that you use then to make inference about the true proportion of red in that jar, or whatever you're looking at, is your point estimate. All right, so down here we have our sample, which is 20 beads from the jar, and our statistic is our pea hat of 0.35. And again, this is our point estimate, the statistic you get. That's your best guess so far, right? Okay, the population would be all the beads in the jar. And our parameter, who the heck knows, right? So it's the true proportion of red beads. But we don't know. Well, I know, but I'm not telling you, right? Okay, so population parameter, sample statistic. All we have to go for right now is our statistic. So I'm going to give everybody a chance. Oops. So now you're going to change your point estimate into an interval. I'm going to give them a chance to basically think of a margin of error, right? Because we know that statistics vary, right? So if we would have grabbed a different handful of 20 beads, it might have given us a different proportion, a different statistic. So we need to create maybe like a little cushion, right? And this is called our margin of error. If you read the book or watched the intro video, in the intro video he kind of calls it a catcher, like think of a net. So we're creating something a little bit bigger, right? And the book just describes it of this interval that we're going to try to catch the true parameter. So I'm going to have them choose what their margin of error would be. It's any amount that they want that they can add or subtract. So let's say that we have 0.35 is our point estimate, right? And so what if we add 5%? So we add 0.05 and we subtract 0.05. And so we'll go from 30% up to 40%, right? So this is our interval, and we're hoping that that will catch the true mean, 30% to 40%. Use your point estimate and choose margin of error. So the margin of error was 0.05, so, and then number 4 is kind of working ahead. So use your point estimate and chosen margin of error to write an interval that you think contains the true proportion of red beads. So there it is right there. Margin of error I decided would be 5%. So if I add or subtract, I create that cushion around the statistic, and hopefully I can catch that true proportion between 30% and 40%. I'm hoping, right, based on my statistic. How confident you feel that your interval captures the true proportion? Answer with a percentage. Okay, so, I mean, you don't get to see the jar, so you're at a little bit of a disadvantage, but, I mean, we could be 100% positive, 80% positive, just how confident, what percentage of confidence do you have in this guess? Okay, one of the groups got 27%, up to 33%, that's their interval, that's what they're guessing. And so they had a different sample, so I want you to kind of think, what was their margin of error? What was their point estimate? Think how you'd calculate that. Well, if you remember, they had to add or subtract a margin of error, so we know their point estimate is right in the middle. Dead smack in the middle. So what I'm going to do is I'm going to take 0.27, add 0.33, divide by 2. I'm going to find the very center. There's not going to be any skew because I just have two values here, right? So I know that'll be the dead center of 0.27 and 0.33. Now the margin of error, there's lots of ways to figure this out. You could probably just look at that and think, I think I know what they added and subtracted, right? But just to give you an idea of a formula you could do for this, if you take 0.33 minus 0.27, so we see the range basically in between the first and last number, divided by 2, we'll have our margin of error, which is obviously 0.03, because if our point estimate was 30% and we went up to 33 or down to 27, we minus 3% each time. Okay, one group claims that the true proportion of red beads is 25%. Does our interval support that? No, we think it's between 30 to 40%. All right, so yeah, I'd say no, right? Why not? Well, our interval states that P will be between 30 and 40, right? And 25% is not between 30 and 40. All right, so we just created a confidence interval, kinda, right? Not truly, but the idea of it. So what is a confidence interval? It's a parameter catcher, basically. It's something that we're just trying to pin down that parameter. So the statistic provides us with a reasonable estimate, right? But it's just that, it's just an estimate. So adding and subtracting that margin of error, when we add or subtract that number, it's going to give us some plausible values based off our estimate. So adding or subtracting our margin of error gives us a range, right, of all plausible values. Okay, so you're going to be asked to describe or interpret a confidence interval. And I highly suggest you memorize this. I mean, you can put it in your own words, but by memorizing this, you're going to make sure that you say everything you need to, basically, right? So your confidence level will go here. And then your point estimate plus your margin of error, subtract your margin of error, subtract will go here, plus will go there. So we're going to say we are 80% confident that the interval from 30% to 40% captures the actual value of the proportion of red beads. So we'll put our parameter, we'll describe our parameter in context right here. Okay, so memorize that. We're going to come back to it. So we're going to spend a little bit more time on making sure you know what a point estimate is. So this guy's making, or these people are making new golf balls, and they want to estimate the median distance the new balls will travel, so that they can put that in their advertisement, say, hey, if you hit this ball, you're going to hit it this far. So they select a random sample of 10 balls and measure the distance each ball travels after being hit by this mechanical driver. Here are their distances. So we're going to put that in order real quick. Here's our first, right? So we're finding the median of this sample. We're going to find the sample median. And so that will be our point estimate. It's going to be the sample median. There's no symbol for median, so we just call it the sample median. And I already went through, so that was the first, right? 284 is the second. There's another 284, which is the third. So I put them all in order, and I found that the sample median was 285. And so that's my point estimate, right? That's the best guess I have about the median distance that these balls will travel. Now I'm going to create a margin of error in a second, not on this exact problem, but I would create a margin of error, a cushion, and create an interval to try to capture that true median distance that the golf balls will go. But when hit by this mechanical driver, that doesn't, I mean, you're just going to hit it the same every time, right? So we'll be able to put that in our advertisement on the box, whatever we need to do. Okay, so next, the golf ball manufacturer would also like to investigate the variability of the distance traveled by the golf balls in estimating the IQR. So remember, we're trying to find our point estimator. So we're trying to find a statistic. So we'll call this our sample IQR. And in A, I found Q1 to be 284. And then I found Q3. So remember, the median's the middle. And then you find the median of the bottom half. So we're breaking it up into quarters, right? So we find the bottom 1/4 where that would be, and then the top 3/4 mark. So find the median of the bottom half, find the median of the top half, and I got 287 there. So the sample IQR is 3. Okay. The math department wants to know what proportion of its students own a graphing calculator. So they take a random sample of 100 students, find that 28 own the graphing calculator. So our point estimate here will be a p hat, which is 28 over 100. Okay, so a few more practice problems on confidence intervals before we go on to margin of error. All right, so read through this question if you haven't already. Okay, so we're going to interpret this confidence interval. So they tell us the confidence level right there. We have our interval, and then we have context, right? So we're set to go. And I have it memorized. If you need to go back and look in your notes, what you should put here, or you can just put it in your own words. We are 95% confident that the interval from 0.175 to 0.225 will capture the true proportion who would correctly answer nitrogen, right? Now, how did I know the context? Well, obviously I read it first, but also usually it'll say, not always, but usually it'll say in there the context of what that confidence interval is about. So you're kind of just picking out the pieces and putting it down. Okay, so now we need to calculate the point estimate. So right in the middle of 0.175 and 0.225 If you can figure it out in your head, that's fine. If not, remember you just take them and add them together. Doesn't matter the order when you add them, obviously. Divide by 2, and I get 20%. Now my margin of error, I'm going to have to take the bigger one, subtract the smaller, divide by 2, right? Because if I subtract them, I find the distance in between, and then I half it, and I'll find what was added and what was subtracted. So the margin of error is 0.025. All right, so if people guess one of the 4 chances at random, about 25% should guess the answer correct. Does this interval provide convincing evidence that less than 25% of all U.S. adults would answer this correct question? Kinda, right? So we're in between 17.5 and 22.5. So, and we're 95% confident that we captured the true proportion. So, our interval is less than 25%. Okay, a large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day on average, the company provides a pedometer to 50 random selected employees to use for one 24-hour period. After collecting the data, the company reports a 95% confidence interval of 4,540 steps to 8,473 steps. Interpret the confidence interval. So if we imagine this, right? The company, maybe there's tons and tons of employees in many states. We don't know. But they need to simplify this for some reason and find out how many steps are people getting. Now, they're not going to know the true average of how many steps people are getting unless they do a census, right? And they're not, obviously. So they did a sample, okay? Now, they took a mean of their sample of 50 people. The mean is their point estimate. It's somewhere in between, right in the middle of their interval. And then they found a margin of error that they added or subtracted, right? And we'll take care of that in B. So we need to interpret this confidence interval. They tell us their confidence level, so we are 95% confident that the interval 4,547 to 8,473 captures the true mean steps an employee takes per day. So point estimate, I added them up, I divided by 2, I got the 6,510, which means they added 1,963 above and below that, trying to capture that true mean. Recent guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guidelines on average? Yes, right? We did not capture 10,000, so we're guessing that the true mean, right, like we interpreted, is in between there for this company. So I mean, they're quite a bit below, according to our data, and we're 95% confident in our data. Okay, so some properties of confidence intervals. Our margin of error, we're going to study more next time. So it's going to be a critical value, which basically is going to be a z-score. So how far away are we willing to go from the mean that we're guessing? And then, of course, a standard deviation, which will give us a value there, okay? So whoever's creating the confidence interval is going to find their confidence level. If you wanted to find, on average, how many people survive a surgery, you're going to want to be like 99.9% confident. We can't ever say we're 100% confident because our interval would be extremely small, right? Because we could say 0 to 100% people will survive from this surgery, but no one's going to be impressed by your confidence interval. So the user chooses the confidence level, and then the margin of error will follow that choice. We'll talk about that real quick. The critical value, which will actually be a z-score, depends on the confidence level and the sampling distribution of the statistic. Greater confidence is going to require a larger spread. meaning, that range of our interval. So if we want to be more confident, we're going to have a bigger catcher, right? So a bigger net. So, and then the standard deviation of the statistic obviously depends on n, as we learned last chapter. So take a look. This is all the same data, but so I just used an applet, and then I changed the confidence level or the sample size. So they're all the same data. So as you can see, they're all centered around 138. So our point statistic was 138. And then I could add or subtract and create a bigger, add or subtract the margin of error based on confidence level, sample size, and standard deviation, and create a bigger catcher of that, right? Or a smaller. So as we can see, 95 to 99.7, they had the same sample size and the same standard deviation because they're the same data. But I was more confident, right? Which means I had to go out more. The more confidence, the more standard deviations you're going to go away from the mean. I went 3 standard deviations above and below the mean to be 99.7% confident. So if you remember, 68% of the data is within 1 standard deviation. So if we wanted to say we're 68% confident, 68% of the samples are 1 standard deviation away. So if 138 is our point estimate, right, 68% of the samples will be there. So we're hoping that our sample did capture that true mean. We'll only be 68% confident, right? And then if I go out 2 standard deviations, 95, 3 standard deviations, 99.7. So that's why our level is going to make our catcher bigger or smaller. Okay, so the more confident, then the bigger your margin of error will be, which will mean you have a wider range of what your guess is, which some people might not be impressed, right? So if you're saying, I think our true proportion is between 20% and 80%. That's huge, right? Well, they're like, that really doesn't help me, right? But you're confident in it. Okay, sample size. As we increase our sample size, that will decrease variability and therefore decrease our margin of error. So, a goal here is to have the biggest sample size possible. Now, standard deviation is obviously going to affect that, right? Because how many standard deviations, we're going to multiply it by it to find our margin of error. And so our standard deviation, if it's big, it's going to create a bigger window. So by increasing our sample size, we decrease our standard deviation. So this really has a lot to do with sample size. So let's talk about this confidence level a little bit more. So this is a sampling distribution. And of course, our sampling distribution, as long as we do everything right, meet all the conditions, will align itself with the true mean. And so as we sample, right, we could sample here, we could sample here, our sample could have been from here, it could have been right here, right? So our point estimate, we don't know where it's coming from in that sampling distribution. We have no clue, right? This is not information that we know. If we knew that information, we'd already know the true mean. So most of the times we go in this and saying, I hope this is right on the money, but it's not, right? So as you can see, 68% of the samples are going to be right very close, okay, to the true mean. 68% of them are. If we go out 2 standard deviations, right, 2 standard deviations away, or 95% of the data lies. 3 standard deviations, 99.7, right? So if we go out from there, I barely missed that guy. It misses the true mean, right? All the rest are within there. So when we find our point estimate, that's why we have this margin of error. So as we go out, our margin of error is hopefully still going to catch that true mean, right? Now this is the only one that didn't capture this true mean. This black line represents the true mean. All the other ones did. Okay, so in this sample, only one did not. Because I mean, if I would have done way more, we would have got, depending on how many standard deviations away they went to create this, that's going to impact if we actually catch it or not. Okay, so that's what we're talking about when we say we're 95% confident. Depending on how many standard deviations out we went, we're hoping that we did catch that true mean. Maybe this is our x bar that we have. Did we capture the true mean? With this one we did with our margin of error, okay? But if we're 95% confident, 5% of the time we're going to accidentally get samples out here or out here. And then if we use that margin of error, that's only 2 standard deviations long, right? If we're only 2 standard deviations long, we're not going to capture that true mean. So that's what we mean by our confidence level. All right, so according to the American Community Survey, a 95% confidence interval for the median household income in Texas during 2009 to 2011 is $58,929 plus or minus $218, right? So we want to interpret this confidence interval. So this was their sample. They sampled a lot of houses. They didn't go to every single house in Texas and ask them how much they make, but they sampled enough. And I went to this website and looked at a sample that they took. So if we take many samples, oh gosh, I can't spell, sorry, and calculate a confidence interval for each point estimate, right? Like we did up here. So this represents a point estimate, and we calculated the margin of error, and then we created a confidence interval and did it over and over and over again many times, right? So if we take many samples and calculate a confidence interval for each, about 95% of them will capture the true median income, household income in Texas. Okay, so this is another one I suggest you memorize. This will change depending on what your confidence interval, and this will change on your context. Okay, so to wrap it up, as part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval 3.14 to 3.52 captures the mean GPA for all students at her school. So we're going to interpret the confidence level. Not the interval, the level. Okay? So after many samples, creating confidence intervals, about 90% of them will capture the true mean GPA for all students at the school. Explain what would happen if the length of the interval to the length of the interval if the confidence level were increased to 99%. So if we increased it to 99%, we'd have to go out farther, right? So if we increased it to 99%, then our interval would be wider. So instead of 3.14 to 3.52, it'd be like maybe 3.5 to 3 whatever. Okay? How would a 90% confidence interval based on a sample of 200 compare to the original 90% interval? So she only surveyed 25 students. So if she bumped that up to 200, then her interval, that would affect the standard deviation, and the interval would be narrower. Right, so it'd be smaller. Describe one potential source of bias in Ellery's study. Well, she's having them say it out loud, right? So if you have somebody say something out loud there, they might be embarrassed or they might not remember, right? So they don't have to go look it up. So a lot of things that could go wrong, but this is called response bias. Okay. So some common mistakes I see in 8.1 before you start on the homework. Make sure you're reading. Are you supposed to interpret the level, like how confident you are, or the actual interval that's trying to capture that? Don't mix those up, okay? And then I have some students think a larger sample size increases the confidence level. No, right? So our sample size affects the standard deviation, not the confidence level. So when comparing a 95% confidence that was created from a sample of 100 to 95% confidence that was created from a sample of 50, no, right? They still have the same probability of capturing, right? The same chance of capturing that true mean. It has nothing to do with how many you sample that, right? So it's not how many you sample, but how confident you are. I mean, we could have a smaller, let's look back here real quick. So even though it was narrower, right, we sampled more, 95%, they're just more close together, right? So it doesn't change our confidence. We might sample out here, we might sample out here and not capture the true mean. So 5% of the time, we're still not going to capture the true mean. So it has nothing to do with how big our sample is of how confident we'll be. Our confidence level is just what we decide how many standard deviations we're going to go out. All right. If you have any questions, let me know, but that is 8.1.